Hello and welcome back. Today we will continue the video series where we try to start up the full storage ecosystem with the minimal number of configuration and with maximum understanding. So in the last video we started the most important component, the satellite API itself, which just enough to store embedded data in the database. But the end of the video, I just magically created the access grant, which is used to access the satellite API. And the question is that how can we get the access grant after a fresh install? Well, it can be retrieved from the UI, but having a UI is far from here because we need a lot of other components. So how did I do it? Well, for understand this one, first we need to understand that what is the access grant exactly. So let's talk about an average service. Usually, to do any kind of authenticated workflow on this service, the most common pattern is that just we have a user and a password, and together with some request, we just send it over. So and that's the most basic one, right? And usually, if it's an API, it's possible that there is an API key instead of the username, and one user may have multiple API keys. And instead of a password, it's some randomly generated thing which is not defined by the user, but defined by the service and given to the user. In that case, it can be some API secret, for example. But that's not the only pattern which exists, because it's also possible that this generated thing, which is given by the service, contains some additional information like role equals admin or write is disabled and so on. But in that case, it's not a random thing, so somehow it should be proved when the request is coming in that this is true. So the common solution for this one is using a signature. So let's say this is the signature, and for any kind of signature, we need a private key. And the private key should be secret. So let's see here, we have the private key. In that case, the service can generate, instead of the random number, it can generate this message with a good signature, and if the signature is valid, then this request will be accepted. So this is, for example, how the JWT web tokens are used. But we can make it even slightly more safe, because we may have multiple private keys, one for each API key. So let's say this is the private key 1 for the API key 1, private key 2 for the API key 2, API key 2, private key of, something like this, key of. In that case, when somebody is sending a message, what should we do now? So there is a signature and an API key, so somebody is sending a message. So still, we need to check in the database which is the right private key based on this API key value. Oh, this one, and we can check the signature. And this is exactly how does it work in storage system. So this is the API key. You need this one. Here we may have some restrictions. We will see the details later, and the restrictions can be sent to, or actually the full message can be sent to the service together the request what actually is required. For example, upload data or list data, and so on, together with this authentication information. So this is how does it work. So when I tried to use the system, then I did an export access grant, export uplink access, and here you need a file. like the test grant. So let's check this test grant. Oh, this one. So this is a usual test grant which is used, so this is the authentication information. But actually, this is not only the authentication information, but some kind of extension. Because what we have in this access grant is that we have the signed API. So this is the API key together with the identification information, the data itself, which is signed. So here we have the signature. But in addition to this information, we have two more information. One is that the real address. So that where is the port what we use. And it's just not the address, but usually in the storage ecosystem, we also have some random characters here, which is the TLS certificate, or actually the hash of the TLS certificate. We covered this one in the previous video about the identities, but this really helps to connect only to the satellite what you would like to connect it to. Because this is some kind of certificate pinning. If the certificate hash doesn't match with this one, then we couldn't connect it. So it's just some extra safety. So this is one part. The other part here is that everything is end-to-end encrypted. So if we have the request together with this authentication information to get some data, we will get some data, but we couldn't read it because storage doesn't store the encryption information. So we need to store the encryption information somewhere here, or the encryption secret, just to make it possible for the local client to encrypt the data when it's retrieved from the service. We can encrypt or decrypt it when we read it with the help of this encryption information, and after that we can read the data. So that's how does it look like, and let's check first the structure of the test grant, and after that we can just dig deeper that what information is decoded here. So there is this uplink access inspect command. So if we use this test grant, we can just, so this is a protobuf which includes a few other bytes and encoding, but we can just decode the full thing here. So what we see here is this is the satellite address. So this is the what we have seen here. So the first part. You see that we have the certificate pinning part, the identity, and we have the address. That's good. We have the API key. So this API key is this part all together, signature, everything together. So you see that it's encoded to one string. And we have the encryption access, which is the last part, this part. And this includes not just the key to decrypt the stuff, but also that which encryption scheme is used. So we need to support multiple encryption schemes, so it can be changed, but the client should know that how to decrypt the data. So there is one remaining stuff here, is this macaroon. So the question is that what is this macaroon? And actually, this macaroon is nothing more just the format or the parsed version of this API key. So this API key and this macaroon is exactly the same. I think it's possible to encode or decode. It's probably base 50 decode, or who knows, 64. Yes. And you see that this is a lot of 00000, which is supposed to be the same as the head. These part contains the restrictions, what we did, and this is the signature. So actually, this macaroon is the same as the API key, just in a parsed form, and this head is this one, the API key, the identifier of the key. And for each identifier, we have a private key on the service side, and this signature is this one, the tail. And this part is just this additional information. So the question is that what can we store? Why is it good to have this additional information? And it's a very powerful part. So let's check it. This is from the Storj Illustrated repository, what we used last time as well. And this shows the details of the macaroon itself. You can see that we have the head and the tail and all the restrictions what we have. And on the satellite side, we have an API key stable where we have the same thing. We have the head, and actually not the same thing because we don't store the signature, we store the secret. So only the server can check if this macaroon is valid or not. So this head, and this is a random unique identifier of this key, the API key, let's call it. So why is it good? So the interesting property of this macaroon that anybody can restrict access based on a macaroon. So this is how does it work. So the signature is based on the actual secret, right, which is known by only the satellite API and the head, the unique identifier. But if you put any restrictions like disallow read, then you can generate the signature from this one. So this one, anybody can do it, right? So this one can be done anyone. If I have an access grant, I can further restrict the capability with just adding more information to here and generate the signature, because I don't need the secret. I need the previous signature, right, the previous tail, and I need to add all of these and just create the signature. So I can create this one and I can just give it to somebody else, right? I can even add one more thing and I can give it to somebody else. So the nice thing is that because this signature is a one-way operation, then if I give this one to you, you couldn't get the previous one. So without server-side operation, I can just further restrict the capabilities of this API key, but still the satellite can check this signature because the satellite does know how it can be done, and it can just from the beginning it can generate this one because it has the secret, and from this secret it included in the middle part this disallow read. So it's very easy to generate the signature. So one way it work only from left to side, and both the satellite can do it because it has the secret. I can also do it because I don't have the secret, but I have the first version of the signature if I have this API key. But I don't have the. But if I give it to you, you couldn't do it. So you can just use the restricted view. So let's try to do something like this. So first of all, I set it, but I use fish shell, so I need to set it with set -x instead of export, and without equal actually. So that's fine. And now we can check the uplink access command, and you can see that we have this inspect. This is what we used. We have the restrict. So let's check it. Access restrict. Oh. For example, we can do some disallow reads or disallow writes. Let's disallow writes, disallow list. So this is a new access grant. So let's check it. What's inside? Uplink access inspect. This is the new access grant. And you can see that from the previous one, the satellite address supposed to be the same as before. The encryption access key supposed to be the same. There are very particular use case when you use multi-tenant one bucket with multiple encryption key. In that case, it can be changed and you can change it, but that's a full separated video, just explain. Probably we will cover it later. This API key is totally new, but the head is the same because the head is the API key, the identifier that's supposed to be the same all the time, right? This is how can we get the secret on the server side. This one is totally new because we just generated based on the new restrictions, and you can see that it's included. So we can just put more and more restrictions here, like even time-based restrictions or whatever is supported. So we can do prefix-based restriction, right? So, for example, that if you give it to somebody, she or he can just read the content from one subdirectory. So read only, yeah, this is the prefix and not before or not after. It won't be accepted by the satellite if it includes and not after, and it's expired. So that's what we have. One thing what we can just do is just to check the database as well. So I'm starting quickly a full storage, and you can see that I have just one entry and I have some name just to make it easier to manage it from the UI, but the head is the unique identifier, and I assume this is the head because I generated test data in the previous example. I know the head because I wrote the code which generated the test data. So I also know the secret, so actually it was quite easy to create the access grant. And what I did in the previous video is that we also have a uplink access create, which is just a helper method to create this the previous full sandwich. This is the same thing what we covered last time, just it's horizontal, not vertical. So you can see that we have the first part, the satellite address, we have the second part, this macaroon, and the last one is the encryption access. And this was the macaroon. You see the identifier and the signature. This is the satellite address, the host port, and this is all of the other encryption, what we don't cover it now, just the default version. So actually this is what we had in the previous diagram, these three stuff. And these are the ingredients. So if you have already a satellite address, it's not changed. For me, it's changed, so I had to replace the satellite address. I had the API key, that's always the same because I used the generated test data, which shouldn't be used in production. And actually, encryption access, I can just use some password and nothing more. So that's all what I need. So let me do an uplink access inspect test grant. Here is the test grant, and after that uplink access create. I prefer command line, and the ingredients is that I need a satellite address that might be changed with starting a new example. So I just modified this one. For example, if the ID, the TLS ID is the same, that the port is different, I can just change it. I need an API key that should be the same if just the port changed. This is the API key in the encoded form, but this is the content. It doesn't really matter. I wouldn't like to do restrictions. And I can choose, okay, passphrase. I can, I would like to give a passphrase to make it end-to-end encrypted. And okay, it's not running. I just stopped everything. But actually, that's all what we need to create the access grant, and after that, it can be used. But still, we didn't cover that. How can I get my very first API key if you don't use the generated test data in a production database? Well, you can use the UI, but the UI is still not working, right? We just started the satellite API, not all of the other edge and other parts. So probably the easiest way, well, you can insert a API key with SQL, but that's not the most convenient way. So the easiest way is just use a REST API because we have a satellite admin component. Which does have some very simple API to do these kind of stuff and modifying limit, modifying projects. So probably that's the next component what we should start, but that will be the topic of the next video. So see you next time.